Oops, good afternoon. Thank you for joining us in this, during this presentation. I will give just a brief introduction because all the attention should go to the researchers which will come later. I work for the category company wear, which is something from the central government. We buy workwear for all uniform wearers in the government. We face challenges by buying these items. We have to deal with the policy making of the government, which claims that for example, the Netherlands should be circular in 2050. One of the things we want to have during the time is more use of recycled content, and that is because we want to cooperate to minimize the huge amount of disposed garments. But to get there and to get more recycled content, we face issues. And we think that when we face those issues, we are not the only ones. Also, the rest of the market will face those issues. And therefore, we started to research those items, and therefore we came in contact with the Saxion University, and we did some really good researches. For us, it means we want to participate, we can finance those researches, but we don't want to keep it for ourselves. We want the entire market to have benefit of it. So therefore, this is a first part to share it with an audience. And therefore, it shouldn't be me on stage, but it should be the ones who are doing the great job. And therefore, I will first give the stage to Theresia Gevinga, who will tell more about the project of Signwear. So, big applause for Theresia.
So as said, I'm Theresia Gevinga. I'm a researcher at Saxion University of Applied Science within the research group Sustainable and Functional Textiles. But first, before I start with the projects, I'm going to tell you briefly something about our university. It's a big university. It's staged at the eastern part of the Netherlands. We have 60 bachelor and master programs, but we are now focusing on our bachelor program about textiles, of course, and we also have then one master program in innovative textile development. We are situated in Enschede, Deventer and Apeldoorn. When we look at our research center, we, of course, because we are a University of Applied Science, we are in so-called technology readiness level in the stage of 5 to 6. So not really scientific research, but more in the middle and just before go to the market. This is our research group. Our professor is Jan Mahi. He's also sitting here in the audience. And we have two pillars. One is about sustainable textiles and the other one is about functional textiles. And of course, sustainability plays a big role in all the projects, but we still divided it into research lines. I'm working in the sustainable textile line as my colleague Jens Ulrich, who is coordinator of this sustainable textile research line. Okay, now I'm going to start with the projects we are doing at the moment with the Ministry of Defense. We are doing and did also 4 projects. This is the project Signwear. We started in 2020 and we are ending it by the end of September. And Jens is going to tell you something about the other 3 projects, is RECAN 1, 2 and 3. In this project, to investigate the technical conditions under which textile products used by the government can be considered circular. As we all know, we have still a linear economy and which has a negative impact on the environment. And our Dutch government has the ambition to become circular by 2050. And of course, the Ministry of Defense is a big part of it. Yes. The aim of this research is to understand the conventional garments that are not considered circular. What are the requirements and in what way can we contribute? and make it more circular. And it's not often known what the content of certain fabrics are, what garments made of. So it's good to investigate that and to do research on the different kind of items within circularity. The goal of this whole project was to drawing up protocols and preconditions for the choice of materials, and also the traceability. And traceability is something we also are doing in the other projects, Weekend 1, 2, and 3. And in this case, we also had a focus on design for recycling, but also the design of maybe new textiles. And in the end, of course, to develop a more circular line. Now, gather information, of course, but this is also important for the futures when working with other stakeholders. What are the rules they have to act by, and to make everything more circular? And this also provide the inside information, and that is an added valuable in general, I believe. As said, we are a University of Applied Science. Within our research center, we use a lot of students who do their research within our projects. That can be bachelor students who will do their internship, but also do their final thesis. And we have master students who will do their final thesis. And some of them worked in this project, Signware. I will highlight two of the master student researchers, and the first one is of the research of Loes Simons-Rietman, and her question was: how should specific components of a circular functional garment be designed and developed in order to contribute to the circular economy goals of the Netherlands? Her focus was on the design process, on this whole process, so she didn't look into the textiles or in recycling in general, but her topic was design. And the focus was the man jackets of the Royal Dutch Army. And she came across, of course, this research will take about half a year, and there were some key drivers and some key barriers. When we first look at the key drivers, we can say that there is a lot of change in production, in more sustainable production, and in the consumption of textiles. But when we look at the design technology, there is also some improvement made when compared to several years ago. The whole design process is more digitally. Also, the sampling process is more digitally, and in the end, that makes it more sustainable. Customer awareness is also one of the major topics. Every customer, you and I, are becoming more awareness about the importance of sustainability, of a closed loop, so to say. And this can give pressure to how to produce more circular. So they have questions and they have demands in that case. And as Aletta also mentioned, government policies, enforced laws, regulation on waste treatments are very important. But besides these key drivers, we unfortunately have still key barriers. And in this case, technological barriers. All the other speakers mentioned it as well. We still have some barriers we have to face and do research. For example, a lack of technology for sorting clothing consisting a blend of fibers, or for minimizing the degradation of materials during the recycling process. And other barriers, the economic and financial barrier. In most of, hopefully, sustainability is a priority in a company, but most of the time money still is the priority. And you could say that management's decisions sometimes prioritize profit growth over sustainability. And of course that should change, but we all know that will take some time. And then knowledge barriers. Often is said that designers play a big role in this whole closed loop system to make everything more sustainable. And of course, that is the case. But often there is a lack of knowledge before they make the right sustainable decision, because there's a lack of knowledge about weaving or knitting. So we should co-create and work together to make it more sustainable in the end. And then the social barriers. Consumers are more aware about sustainability, but are often still concerned about the quality conditions of, or hygienic conditions of the reused and recycled products. And that has everything to do with image, of course. Loes, she identified and adapted 5 circular design strategies, as you can see here: design for long life use, design for disassembly, design for adaptability, and design for recovery and recycling. All important things, and I don't have the time to go deep into that. So she had to focus on 3 other things: construction design, construction techniques, and haberdashery. That's another nice word for zippers and buttons and so on. But when we look at the construction of the design, she mentioned that design for disassembly is very important, and also include alternatives or replacement pieces. So if a garment is worn out, you don't have to recycle this whole jacket, for example, but maybe only the sleeves. And she's also arguing that it's better to have a timeless and more simplified design that is also more sustainable. When we look at the construction techniques, preferably do not use sewing thread that contains material other than the textiles, and to allow easy removal of panels. And for the haberdashery, avoid haberdashery as much as possible. And of course, sometimes that is not possible, but as much as possible. We can start small and maybe then change more. And for easy removal of these haberdasheries to facilitate the recycling process. She made some suggestions. She worked with screw buttons attached to the uniform, so easy to remove and therefore easy to recycle this jacket. She also looked into the construction of the pattern making. On the right side you can see the patterns as they are now, and the left side she simplified this whole jacket with less panels, and that makes it more sustainable in the end. The other student is Roos Herder. How can you choose, can the choice of alternative textiles increase the circularity of the products? And she focused on the textiles and on the recycling, so not on the design part, but pure on the textiles and the recycling. And she worked with the 9R strategies. I think you all know them. These are divided in 3 categories: smarter use product and use manufacture, extend lifespan products and its parts, and useful application of the materials. She dived deeper into that, and then she noticed that, of course, the Ministry of Defense already worked with those R's, but mainly with a focus on recycle, repurpose, reuse, and rethink. And after her research, she suggests that it would also be good to think about repair, refurbish, and remanufacturing, because that will increase the level of circularity. She dived also deeper into, because she used 2 trousers and 1 shirt, and she analyzed everything about those garments. She looked into the haberdashery, in the textiles, in the whole construction, and she looked at the blend of the textiles, and maybe sometimes the materials were not recyclable at all. she did a lot of tests in our Saxion laboratory, and she did the pilling, abrasion, resistant, and so on of all those garments, and she made some suggestion for alternative textiles. And she did that to prepare for a good LCA analysis. And the conclusions were that a garment made of tensile rPET has properties that meet the requirements, because workwear has other requirements than the fashion industry of these garments, and lower the environmental impact. But for the shirt, there was not a suitable replacement, and due to higher impact on the climate change and the use of elastane, and that's because the shirt should be comfortable, and unfortunately there was not a suitable replacement. And when we look at the lifetime extension and reduction of weight, she mentioned that decreasing the weight of the material and increasing the lifetime of garment lowers the environmental impact and all impact categories. So that was in a nutshell what we did in the project Signware. It's still the end of September. I'm writing the end report as we speak. So, and now Jens is going to tell you something about our RECAN projects 1, 2, and 3. Thank you.
Okay. Thank you, Theresia. The time is almost over, but I heard that I can extend it a bit. No problem. So, what we actually wanted to develop at Saxion together with the Minister of Defense was a method how to analyze how much recycling content is actually in a textile product. Because the Minister of Defense, they do tenders, they ask for a certain recycling content in their garments and in their other textile products. But at the end, nobody, if you have the product, can actually measure afterwards how much recycling content is in there. So what we did is we gathered a consortium of partners that were interested in this question, and we performed research to make an analytic tool to be able to identify the recycling content in textile products. And that's a long way, because you first need to find analytic methods that can actually detect and quantitatively determine the content of recycled materials. And as you know, mechanical recycled fiber, if it's cotton, it actually has kind of the same properties as a virgin cotton. But there are some distinct differences that we might use to get a quantitative method for determination of that. We focused on cotton fibers and that of mechanical cotton in cotton products and polyester cotton blends. So what we found actually that there are 3 different analytic methods that we can use to identify recycled content in textile products and maybe also quantitatively measure the real content. First, to distinguish mechanical recycled fibers from virgin fibers, you can use microscopic imaging. Yeah, you can look at the fiber ends, for example, and we can use our fiber length distribution measurement, and I will go into detail later what that means, to actually show that there is a recycling content in a product. And then there's also a way to distinguish pre-consumer material from post-consumer material, and that could be done by the degree of polymerization of that cotton product. If you look under a microscope, you can find a lot of differences in fibers, and of course those differences are not big. And if you analyze a textile product, you can see that you can have a lot of different ends of fibers. If you use a natural cotton fiber, as in the first picture, it has a very distinct end, but you can see also when there's mechanical recycled fibers in a product, other endings of those fibers, which could be a cutted end, which comes maybe from the recycling process, or a worn and torn end. And we had some examples that looked like this, where you might see that it's torn apart, which could also be from the mechanical forces. And then what we can do at Saxion now is to measure the fiber length distribution in a batch of fibers. That actually means we can measure what fiber lengths are in a certain batch, and you can get those kind of graphs as I show them here. And with some statistics and mathematical manipulations, you can actually distinguish them into two Gaussian distributions, as it's called. And you can find two distributions in this type of garments. And when you calculate that out, what it means, what is the total length of all the fibers you measured, and what is the total length of the first Gaussian distribution, then you can come up with an estimation of the recycling content in the product. And in this example here, you can see that it's around 30%. The degree of polymerization is actually that we look at the cellulose polymers in cotton, and they have a certain length. And when you harvest cotton, the polymers are longest because they are not treated. So they are between 3,000 and 8,000 monomers in length. And when you treat them in the textile production steps, textile processing, and you bleach the cotton and you handle it, then the DP, the length, will be reduced. When textile comes onto market, it depends on the quality of cotton. The DP is usually above 2,000. And when you then wear it and wash it and use it for several times, you actually lower the degree of polymerization. And at some point, it's really the cotton is broken and will fall apart. And that is about 1,000 monomer units. But there in between 1,000 and 2,000, you have a range where you could estimate if it is a fresh cotton fiber, so more like a pre-consumer recycled fiber, or if it's already washed a lot and worn a lot and treated a lot, then it goes down and it's more like a post-consumer recycled fiber. So that might be useful for analyzing recycled fibers as well. So the conclusions are, it is possible to discriminate mechanical recycled cotton from virgin cotton by optical microscopy and fiber length distribution. It's also possible to discriminate pre-consumer cotton from post-consumer cotton by measuring the degree of polymerization. But that's not, we are not there yet. We don't have an analytic tool because we first need to verify how exact we can measure those things, how well we can make those measurements and the conclusions we can get out of that. So what we need to do and what we are currently actually investigating is we make prototypes of garments where we know exactly how much mechanical recycled fibers are in there. And afterwards, when we have those prototypes, we analyze them and see what is the deviation between what we put in there and what we analyzed. So we also develop a procedure to get the fibers out of the garments without damaging them, because that is very important when you want to measure the fiber length. When you damage them already, when you take them out of the product, then you are screwing your measurements. And we need a test setup where we can perform then a qualitative and quantitative measurement and write a protocol for that. And if that works out, we can maybe connect that to the presentation we heard yesterday from Edwin Maas from Textile, who talked a lot about standardization and EU regulations. And if we have such a measuring tool, we might connect it to standards that everybody can use it and actually analyze the the recycled content in their garments on the wool products. That was actually the end of my presentation. Thank you.